Hello, Assalamualaikum, and welcome to our presentation on Bellman-Ford Algorithm, presented by Varda Fatima and Arid Zahra. This algorithm is used to find the shortest path in weighted directed graphs even when there are negative weighted edges. So we're heading towards our presentation. And the first one is table of content, where we will discuss about introduction and why we use the Bellman-Ford in our data analysis and key concept, algorithm steps, pseudocode, and all that in our presentation. The first one is our introduction. What is Bellman-Ford algorithm? The Bellman-Ford algorithm is a shortest path algorithm that handles negative edges unlike the discrete algorithm. It's named after the Richard Bellman and Lester Ford. Here we have the pseudocode. We define a function called Bellman-Ford that takes a graph and source node as input, initializing the distance. Here we initialize an array to store the shortest distance from the source node to all the other nodes. We set the distance to the source node itself to 0 and all other distance to infinity. So starting from here, we start a loop that will run 5 times, where v is the number of vertices. We can say is v5 or what, and the other is inside the loop we iterate over all edges in the graph. For each edge we check if the distance to the destination node can be improved. Then here if the distance to the destination node can be improved, we update the shortest path. Then heading toward the distance. In distance for in distance, if the destination node can be improved, we come to the shortest path, and then after the loop finishes, we do one more pass over all the edges to check improve the distance to any node. It means there's a negative weight cycle in the graph. So we are heading toward our time complexity, the time and space complexity. Let's talk about the time and space complexity of the Bellman-Ford algorithm. Let's talk about the time and space complexity of the Bellman-Ford. The time complexity is this, where v is the number of vertices and e is the number of edges. The space complexity of this ov for storing the distance array. So we're heading toward our pros and cons. The pros and cons include, however, the Bellman-Ford algorithm also has some disadvantages. It also slower than discrete algorithm for graphs with positive only weight, and it's not suitable for every large graph due to its time complexity, as we have seen this OVE. V are the number of vertices and E are the edges. So we are heading toward our real life application. So where is the Bellman-Ford algorithm used in real life? It is used in network routing, such as in RIP protocol, currency arbitrage, detection, and finding in shortest path in road network with jitters and penalties. So now we are heading towards our conclusion. The conclusion includes the Bellman-Ford algorithm is essential for finding shortest path in graphs with negative edges weights. It handles negative weights, detects negative circles, cycles and runs in its time complexity. We have discussed that on the previous slide, making it suitable for sparse graphs. Overall, it's a vital tool for various applications in graph theory.